According to the diffusion of innovation theory, only 2.5% of people are making inventions in the world. We live in an era where the world needs more inventions to save the planet. So, what if everyone has the potential to invent, the world going to be a lovely place? So enabling everyone to invent will really contribute to the long-term aims of sustainable development. The invention landscape in the current environment is driven especially by technologically enabled inventions. This is commonly referred to as digital change. I am Aruna Dyanatha, director and conceptual leader of A Little Beginning in the Indian Ocean from a small island named Sri Lanka. The popular belief is that IT professionals must conduct digital change. This, however, is positioned as a fallacy, and even elite institutions provide support to enable non-IT workers in the digital transition to lead invention. In addition, the outside-in approach requirement was supported. The invention to begin with customer experience was at the top of the invention agenda of considerations. This idea is followed by the paradigms of design thinking that are prevalent today. Well, it is possible to make the innovation into a model. There were concerns. The early phases of the movement for creativity, which is over a century old, have advocated that creativity cannot be explained by a model. The group of people who subscribe to this paradigm, however, has been decreasing since the 60s. I have researched several design models on the market, including the Stanford design thinking model that has been accepted to be the most popular of the present day. But Stanford's thinking model's shortcoming is that it does not create a model for thinking. So, the innovation is mostly for people who in a brainstorming session can create an idea that 2.5% of people in the world identified as inventors in the diffusion of innovation theory. This by no means enable everyone to invent. However, I feel it would be helpful if a model were to guide thinking in order to make an invention. I have thus started in search of ideas to develop such a model. I found a product that was marketed as the tile presented for the crowd fundraising platform Indiegogo.com. I used this invention to reverse engineer the thought process of the inventor, so the model could be generalized. Tile solution solves a relatively little difficulty, experienced by everybody. Yet, this is a major issue daily. This invention has offered an IoT gadget that can be tagged into almost anything and that can be located on a smartphone using an app if it is misplaced. The smartphone app provides the location indicated on a map, so if the item is lost, can be relocated. This product leverages the power of connectedness and the inclination of people to share stuff. As the dumbbell mushroom, we named the framework immersed in our labor. Actions are taken by people to get results. Human efforts are made to intensify acts, so that larger outcomes can be achieved. They acquire technological leverage, so that they can achieve outcomes, with efforts from the lessor. This means that action is moderated, and technological causalities occur. When people utilize technology to control their causal loop activity, they may do the same for intense outcomes, raise the effort a bit and achieve more intensely, or lower their efforts and get identical results. The moderated causal relation was utilized as a foundation for my development of the framework. The final model looked like in the image, when we construct an innovation framework based on the basic moderated causality mentioned before. It looked like a mushroom coming out of a dumbbell. This is what the name is behind. Let me explain the model gradually. Considerations begins by looking for an action to resolve a specified problem, which is the point of departure for any other design thought paradigm. In order to identify issues, we recommend human feelings. Discontent can identify problems experienced by individuals. We are, nevertheless, in favor of distancing the creator from dissatisfaction. In other words, the innovator should distinguish sentiments from the problem while respecting the feeling as an indicator of the problem. An inventor who attaches himself to emotion might destroy the inventive chance. In the case study, the problem identified was how to find anything missing. The creator then focuses on a loop of do and get. The ultimate solution of the invention will be how IT could moderate what people do. That is, the effort exerted to get the results that are expected in doing things. And how IT could be used to moderate the causal relationship of the do-get loop. To find the optimum position in a lateral options ladder, the inventor will create different definitions of do-get loops and detect the best action the innovator can do. In this case, alternatives are propagated and reduced to the best possible level. In a category system of the do-get loops, we use the lateral thought model that shifts between abstraction and concretization. Once the do-get loop has been completed, research is needed to discover what individuals do in circumstances where the do-get loops are practiced. Research may be done by reviewing previous ideas or by understanding what they do with the implementation of a do-get loop. However, this would not be a positivistic approach by any means. In addition, the creator explores what individuals do in other fields, by expanding the do-get loop area. The mushroom roots, I call it. The answer is more complete in this respect since the invention will be anchored in this discovered behavior. By bringing the answer closer to human behavior, on the other hand, the acceptance will rise. In the next phase, a list of action verbs from the behaviors of the roots may be propagated. To create a wider number of action verbs, the scamper method will be employed. These verbs of action are the potential actions to be taken by the solution. Increase the number of verbs, the choices for innovation are higher. At this point, the inventor can create several choices. The combination of a selected action verb can provide a solution. With the combination of another set of action verbs another solution might be formed. In this phase as well as the invention, several models might be propagated and reduced to the best model. The innovator will next extract a variety of capabilities and characteristics from the proposed solution. At the feature level, the characteristics to be merged to execute the selected total action verbs in the previous stage are described. Functionalities are expected to expand the recognized features. In order to identify the characteristics and technologies that assist the operation, the solution should thus supply at the next level. The inventor shall at this point undertake a thorough study of various technologies to create the functionality indicated in the model. The image shows the case study results with the tile solution I utilized in the case study. In addition to testing the model, we tried to test the model in making 3 innovations. They are: 1 was to find a solution to the home's household food waste problem. 2 was a solution to the problem of keys being left unattended. The development of this paradigm will be discussed in greater detail next. The source of our dissatisfaction was my wife's failure to keep the car keys in the right place, where they were meant to be kept in the evening. The keys were occasionally left in the boot keyhole or anywhere. As a result, the solution we wanted to devise was to be able to check at the end of the day if all keys were maintained in a secure area. As a result, the do-get loop that we limited down to provide a solution to the problem was to check the key and make sure that all keys are in the safe position. Other choices for solutions were available. For example, the team who tested the concept rejected the idea of finding the keys and placing them in the box. The idea for the invention was formulated as a result of this. The next stage was to figure out what people do in this situation, or to figure out what people do in the current domain. The mushroom's level 1 roots are known as this. What was discovered is that in the relevant domain, people count the keys, and visually check their availability, to confirm that all of the keys are present. The next step was to look for similar behavior across domains to see if similar behavior existed. Different types of behavior were discovered, in many domains. Calling and speaking with someone from the company's security department to confirm that all the keys are in place was seen as a good idea. In a bowling game, the game cannot begin until all pin slots have been filled. The compound effect of spices was verified by tasting the curry when making curries in the Sri Lankan setting. Ensure that all members are present by having them call out the numbers allotted to them in order. Self-reporting in SWAT teams because they have occupied the appropriate locations via walkie-talkies. Completing the picture in the puzzle once all the parts are in place. Also gathered as level 2 roots, are the behavior of supermarket checkouts that checks for the presence of a token. Key phrases were extracted, from the behavior obtained in the level 1 and level 2 roots, to build the mushroom's trunk. The inventor will construct a solution, using key phrases by matching the key terms. Those important phrases will be derived, from a variety of sources, stemming from the level 1 and 2 roots. Visually check, counting, calling and checking, checking all slots, checking if items are in sequence, activating a self-reporting, checking if the picture is complete, and sense were some of the important terms that arose for the solution being reviewed. When key terms are extracted from roots, it is possible that a larger number of key terms may result. The goal is to create a larger number. To visualize the solution, the inventor has the ability to choose a subset of key terms. To imagine many solutions, the innovator might choose from a variety of combinations. This approach supports the development of alternative concepts, and narrowing down to an effective option. As the features of the proposed solution, derived out of the action verbs accumulated in the mushroom trunk, were 1. Using sensors, sequences, and self-reporting of keys, be able to identify each key individually. 2. Being able to visually repress the presence or absence of keys. And 3. Two machines communicate and gather data from a distance. Functionalities required to establish the features identified were gathered, as in the table. Some of the functionalities, even though were identified, when considered, were later on eliminated from the final solution, aiming at the parsimoniousness of the solution. Thus, the functionalities required were narrowed down to sensing, and keys with a unique ID, in order to establish the feature of being able to identify the keys uniquely. Providing physical slots enabling visual check of the status of safekeeping the keys, detecting if the keys are in place, communication to the owner as functionalities required to establish the feature of being able to represent the presence and absence of the keys. And communication with each other and communicating with the owner were features that were used to establish the feature of two machines communicating to get the status remotely. Required technologies were investigated, and recognized as the last layer of the mushroom button, to offer the functionality of the final solution. The technical prototype definition was produced as a result of this. As a result, the eventual solution was to use RF tags in conjunction with a phone app that could digitally allocate and assign unique IDSN slots. The presence and absence of RF tags, to be detected using an RF receiver. A LED or light to emit light, as a notification of the completion of the collecting of all keys. An alarm to inform the owner of unauthorized access, and Wi-Fi connectivity to connect the device to the Internet. The invention's prototype definition might be given as a table, as it was originally constructed, or as a graphical representation, as seen in the image. This brings the invention process to a close. The dumbbell mushroom invention model completes the processes of emphasizing, defining, and ideating when compared to the Stanford Design Thinking Framework. This framework, most importantly, gives a step-by-step approach to brainstorming. However, this framework will only give a prototype specification, thus, the prototype, testing, and bringing the product to market will all have to be done outside of the framework. I predict that this model can be used in many instances, as shown in the slide. It may be inferred that anyone who follows the dumbbell mushroom innovation model's step-by-step instructions will be able to create an inventive solution. It may be necessary for inventors to be directed at first. This approach, however, is deemed enabling everyone to invent, following training on it. I hope that this quick presentation has piqued your interest in learning more about this model. If you need to reach me, please utilize the options on the screen. Your feedback is appreciated and will undoubtedly be motivating. Thank you very much.